So the last topic in this section is solving equations that are quadratic in form. So sometimes we have an equation that's not actually quadratic, like 6x to the fourth minus 13x squared minus 5 equals 0. That's not quadratic. That's not a second degree polynomial equation. It's a fourth degree polynomial equation. So if we make a substitution, so we're going to let some letter other than x, I'll choose the letter u, equal to x squared. Then that means u squared is x squared squared, which is x to the fourth. So whenever I see an x to the fourth, I can write u squared. So this is 6u squared minus 13u minus 5 equal to 0. So I'm able to rewrite the equation as a second degree equation using a new letter. So I make it look like something familiar and I solve it. So I'm going to solve this by factoring. And I know I need first times first to equal 6u squared. So 3u and 2u. And then I need last times last equal negative 5. So I'm going to put a 1 here, a 5 here. And if I make this 5 negative and this 1 positive, I'll have what I need. 3u times 2u is 6u squared. 3u times negative 5 is negative 15u plus 1 times 2u, which is 2u. So negative 15u plus 2u is negative 13u. 1 times negative 5 is negative 5. So 3u plus 1 equals 0, or 3u minus 5 equals 0. So 3u equals negative 1. U is negative 1/3. Or 3u equals 5, and u is 5 over 3. So let's replace u. Remember we said that u was the same as x squared? We need to go back to our original variable. So x squared is negative 1/3. Or x squared is 5/3. So using the square root property, x equals plus or minus the square root of negative 1/3. Or x equals plus or minus the square root of 5/3. All right, so I will rewrite this as plus or minus I times the square root of 1, which is 1, over the square root of 3. And I'm going to simplify that radical by multiplying numerator and denominator by the square root of 3. Here, x is plus or minus the square root of 5 over the square root of 3. And again, I'm going to rationalize that denominator by multiplying this by square root of 3 over square root of 3. Okay, so x equals plus or minus I times the square root of 3 over 3. Or x equals plus or minus square root of 15 over 3. So remember, the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is 3. That's why I get this 3 in both denominators. So my solution set contains 4 solutions. Negative I times the square root of 3 over 3. Positive I times the square root of 3 over 3. Negative square root of 15 over 3. Positive square root of 15 over 3. And I close out the set. So that's my solution set. Okay, so we get all kinds of situations where we can solve using a substitution. Here we let some other variable. I like to use the variable u. And in this case, that equals the square root of x. And if I square u, I get the square root of x squared. And as long as x is non-negative, that equals 2x. I'm now going back to the original variable. In place of u, I'm going to put the square root of x. So the square root of x is 4, or the square root of x is 2. If I square both sides of this, so this is a square root, a radical equation. I raise both sides of the, once the radical is isolated, I raise both sides of the equation to the power that's the same as the index of the radical. The index of a square root is 2. So x equals 16, or x is equal to 4. So if I put, if I went back to this original equation and check, 16 minus 6 times the square root of 16 plus 8 equals 0. So 16 minus 6 times 4 plus 8 equals 0. So 16 minus 24 plus 8 needs to be 0. So negative 8 plus 8 really is 0. That's true. So that means x does equal 16. Remember, you have to check whenever you solve an equation by raising both sides to an even power. Now let's check x equals 4. 4 minus 6 times the square root of 4 plus 8 needs to equal 0. 4 minus 6 times 2 plus 8 equals 0. 4 minus 12 plus 8 equals 0. Negative 8 plus 8 equals 0. That's true. So this tells me x really does equal 4, because I was checking x equal 4. So my solution set has the number 4 and 16 in it. Those are my solutions. Let's look at one last problem. All right, here's another example where we're going to let our new variable, it can be any variable other than the variable of the equation. So let's let u equal 2x plus 4. So we're going to write this as 6u squared minus u equals 2. So 6u squared minus u minus 2 equals to 0. So 3u and 2 times 2u will give me 6u squared. And let's choose a 2 and a 1. We'll have a negative 2 and a positive 1. And if you check that, try using the distributive property twice and check that. 3u minus 2 equals 0, or 2u plus 1 equals 0. Three u equal 2. U is 2/3. Or 2u equal minus 1. U equals minus 1/2. Okay, so we're going to replace u with 2x plus 4. So 2x plus 4 equals 2/3, or 2x plus 4 equals negative 1/2. So 2x is 2/3 minus 4, or 2x is negative 1/2 minus 4. So in the first case, I need to multiply 4 over 1 times 3 over 3. In the second case, I multiply this 4 over 1, or negative 4 over 1 times 2 over 2. Since my denominator that I'm trying to achieve is 2, here my denominator is 3. So 2x equals 2/3 minus 12/3, which is negative 10/3. And so I have 2x equals negative 10/3. So I'm going to multiply both sides of this equation by 1/2, which is the same as dividing by 2. So here I get x. Here, since 2 divides into negative 10 a negative 5 times, I get negative 5 over 3. Here I get 2x equals minus 1/2 minus 8 over 2, which is minus 9/2. So 2x equals minus 9 over 2. So I'm going to multiply both sides of this by 1/2. That's the same as dividing by 2. So x equals negative 9/4. So my solution set contains a negative 5/3 and a negative 9/4. That's my solution.